going to be the left side of the EcoSec system. And what you're going to notice here in the, oh, I think that's what I want. What you're going to notice here on the EcoSec is that you're going to see a series of tubing. And so what you're going to have here is what I'm quoting is going to be your solvent bottle. And then here on the behind it is going to be your waste bottle. And what you want to notice here is that you're going to have 3 lines going into your solvent bottle. One is going to be your wash line for your auto sampler. One is going to be your solvent bottle. And then one's going to be a moisture line. So the main thing that you want to do is make sure that your solvent line, which is going to be this line right here, enters through your bottle. It goes into the bottle and it's immersed. Same thing with your solvent wash line. So what's going to happen here is that it's going to pump solvent from your solvent bottle into the pump of it, GPC system. So this is going to be the pump of your GPC system. And what you have here is going to be a fan. This is going to be a temperature controlled pump oven. And it also has a moisture detector. So the purpose of the moisture detector inside the system is to detect moisture if there's a leak. So if you have a leak of a volatile solvent, it's going to detect that. After your solvent is pumped in the solvent bottle, it's going to follow this line into a degasser and then go into a T that's going to go into your sample pump and your reference pump. After it goes into your sample pump and your reference pump, you're going to exit the pump oven and then enter into the column oven. So this is another temperature controlled column oven. It will also have a vapor sensor, so when you're working with volatile solvent and if there's a leak inside the system, it will detect that leak based on that vapor sensor. What's going to happen is that you're going to have 2 lines here. One line is going to be for your sample column, and then the other line here will be for your reference column. So you will know which one is your sample column and which one is your reference column by locating this line right here. It's going to say S.pull. So this is going to be for your tubing to go into your sample column. This S.pull will go into your sample column, exit your column, and then go into a line called RI.S. And RI.S will be your sample tubing that goes into your RI detector. The next thing that you want to locate is going to be this tubing called R.pull. So R.pull is going to be your tubing that goes into your reference column. So R is for reference, pull is for pull. This line is going to enter into your analytical column or your reference column, and then exit your analytical reference column into a tubing called RI.R. So this is going to be your tubing for your reference column going into your RI detector. So you're going to place your columns in here, and then afterwards, in the future, if you decide to opt for a UV detector, you will have a UV detector space here where the UV detector can be installed. You would open both the pump oven or you will actually open this pump oven or this column oven by hitting the button underneath the door. And then when you need to close it, you would close the door and then push here where it says close. Same thing for your column oven. You would press the button near the column oven door, open it, and then if you need to close it, you can just push here where it says close. Another important feature to pay attention to would be your display, your front panel display. So your front panel display is one area where you can control the instrument. However, we always recommend that users control the instrument through the software, which is something that we'll jump into. However, upon turning on the instrument, the power button is right here. You just need to press it once and it will turn on and it will boot. In order to open the auto sampler, you would need to press and hold this button right here. Once it beeps twice, it will begin to open the auto sampler. Here is where you would place your sample vials. One begins here in the bottom left corner, and then it will go all the way up to the next number, to the top right corner. This auto sampler, you can take out the sample tray, and then simply slide it back in. You never want to force the auto sampler back in or push on it. You simply just need to put the tray back in so that it is flush. Once the auto sampler tray is flush, in this container, you just press the eject button one more time, and it will slide back in. You also have features where you can also lock your auto sampler and turn on your flow. So this button right here is for your sample flow. This button right here is for your reference flow, and this button right here is for your curve. However, we always recommend that users use the software to control the instrument, which is what we're going to look at next. The next thing that I want to showcase is going to be the right side of your instrument. On the right side of your instrument, you're going to have your power cable and your power switch, and also your PC cable to connect to your computer. One additional feature that you have on your GPC system is going to be this area right here. In the event that you ever need to install a third-party detector, you can unscrew these two screws, and then behind this area will be a outlet for you to plug in via analog signal cables or analog cables to plug in any third-party detector. So to take a look at instrument control, so what I'm going to do is showcase different aspects of the software. Do you mind waiting so that it should be right there? Yeah. That's actually quite good. That should be good. So what we want to do is emphasize how you're going to control your instrument. So So to open the software, you're going to click the icon over here on the left called EagleSec Elite-WS. Once you log in, you're going to log in as a lab user, in which the password is going to be polymer with a capital P. Upon logging in, you have two panels that you can click between. One panel is going to be acquisition. The second panel is going to be analysis. So we are going to focus on acquisition first, and then Justin will take over and showcase analysis. For acquisition, what you see here is you're going to be your online monitor on the left side. You're going to see a flow diagram of the flow path, your pump, your sample tray, your columns, and your detector, and your status here on the right. You're going to see in this bottom left panel your sequence, your sample sequence. You're going to see results here in the next panel, and additional information here of your sample on the bottom right-hand panel. If you need to switch instruments, you can hit this button here in the top bottom left if you have multiple instruments connected to this computer. To turn on and off your GPC system, you can use the power button here. This is going to be a button that will start the warm-up. So once we enter into the instrument control settings, you can actually dictate what your warm-up settings are, as well as what your shutdown settings are. So this would be the button to immediately start any warm-up settings. This is going to be your start analysis. So whatever is populated inside of your sequence here on the left, when you click start analysis, it will begin analyzing the samples that you have listed on your sequence on the left. If your system is running and currently analyzing samples from your sequence list, you can hit a pause button that will pause the sequence, and then you can also hit a button here that will do an emergency stop to stop analysis. We also have settings that you can set up for a shutdown procedure as well. So in the event that you need to you finish your analysis and you want to shut down the instrument, you can click this button and your instrument will automatically enter into a shutdown procedure. This is going to be your acquisition method. This is something that you can set up now or later. However, when you click this button, you will open up you can either create a new file or edit an existing file. So here, you click new, and then you will open up a panel where you can update what your acquisition settings will be. Usually, I leave it as default. However, you can go through it line by line to see what features you want to update for acquisition. Upon closing it, and let's say that you want to edit an existing one, all you would have to do is right-click an existing acquisition file, click Edit, and then edit it as you see fit, and then you click OK. And then it will ask you if you want to save any edited content, and you click OK or cancel. I'm going to close this. Moving past acquisition, you can look at individual conditions. So in this sample sequence, you're going to see the acquisition method here. So I'm going to point here. You're going to see your state, whether or not it's been analyzed or not. In this sequence, you're going to see a cup. So cup is also going to be your vial number. So we're injecting from vial cup 1. The name of your sample, the acquisition method, which we just talked about, the injection volume, the number of times you would like to inject from that sample cup. In this case, we can only do 3 per line. And then we also have individual condition. So individual condition is going to be how long you're going to analyze each sample. So to make an individual condition file, you're going to go to this button right here and click individual conditions. When you hover over any of these buttons, it will also tell you what the button is. In this individual condition, you can either create a new one. So I press the new button, and then you're going to see set the runtime. So let's say the runtime I want is going to be a 15-minute analysis. I want to start my acquisition. So acquisition start time here is going to be at 0.0. And then my acquisition end time, or how long my analysis is going to be 15 minutes. So I want to stop my acquisition at the same time that my runtime ends. And then you can also set your sampling interval. We recommend 100 per ms. Here you click OK, and it will give you the option to save. In the event that you want to edit an individual condition, you can right-click the file, click Edit, and then you can edit it as you see fit. Click OK, and it will give you the option to save your edits. Here, the next button to the right would be to do your sample queue. Upon clicking your sample queue, you will be able to generate your sample list. So like I said, you're going to enter your cup, which is your vial location, the name of your sample, your acquisition name, your injection volume. Here we are using 10 microliters. The number of times you would want to repeat an injection on the same line. So if I were to do 1 here, I would inject 1 time for this line. In the event that I want to do 3 injections in this 1 line, I would set 3. If you want to inject more than 3 injections from the same vial location or cup location, I would make another line right here, as you see here, copying the exact same information, and then enter the number of times I would like to inject from the single line. For each individual line, you can only do a max of 3 injections. So if I wanted to do 9 injections, I would make another line and set it as 3. Individual condition will dictate how long my analysis time is, and also how long I will be doing my acquisition. And then there's also a remarks column for any comments you might need to make. Afterwards, I will click Save As, save my sequence name. So I would put sample, for instance. Click OK. And then I have now saved this sample queue. Now click Close. So the next thing that I want to do is look at my instrument control setting. So this is going to be how you directly control the flow rate, the temperature, and any other parameter of your instrument. When you click this button right here for instrument control setting, you're going to see a panel where you can see on the right is where I want you to focus on. On the right side here, you're going to see a series of controls. You can turn on and off your pump with a toggle button. This button will toggle the flow for your sample pump. So right now we're flowing at 1 ml per minute, and then I can click stop and stop only the sample flow. Right now we're flowing through the reference pump, and I can click stop and stop only the reference pump. Or I can control both pumps at the same time, start and stop the flow for both pumps. So I would simply click stop here. It'll say, do you want to stop sample and reference flows? I would click yes. And the instrument would proceed to stop the flow to both pumps. And if I wanted to turn one on individually, I can do that. Or if I want to turn both on at the same time, I can simply go here and click start. Right now we are setting it so that it will flow at 1 ml per minute. here you're going to see the current values for everything on the left-hand column, and on the right-hand column is what you want to switch to or update to. So in the event that I want to decrease the flow to 0.5 mils per minute, I would go to sample flow and double click here and then update it to 0.5, press enter. Right now it is highlighted green, meaning this is a pending change. Now if I want this to be communicated to the instrument so that the flow rate will actually change, I'm going to click this button on the bottom right here that I'm pointing to, called transmit data. Once I click transmit data, it will now send a command to the GPC system to set the flow to 0.5 mils per minute. We also have a flow rate going to our reference column. Typically speaking, for most methods, we will set the flow rate to be equal to the sample flow. So this is why we have the drop-down option of equal. In the event that we want to change the flow rate going into the reference column, we can set it to 1/4 the flow of the sample flow, 1/2 the flow of the sample flow, make it equal to the sample flow, or make it double or 4 times as much as the amount of flow rate going through the sample flow. For here, we're going to keep it at equal. If we want to have it so that if you're operating at higher pressures or higher flow rates, we can also adjust how fast we want to increase the flow rate or how fast we want to decrease the flow rate after we set the flow rate. So in the event that I set this to 1 mil per minute, I'm going to click enter, and then I'm going to click transmit data, and then it's going to increase at a rate of 0.35 mils per minute. We are also able to set limits for our column pressure. So here we're setting a pressure limit of 25 MPa, so that if the system pressure is above 25 MPa, it will trigger an error and shut down the flow to protect our analytical column. Before any sample analysis, we also recommend that you do 2 things. We are always going to recommend that we purge the pump, and also we also wash the auto sampler. Here is the button to purge the pump. So when you click this button, you're going to be given the option to set how much you would like to purge the pump by. For traditionally, we set it to 150 mils, especially if you're changing from a different solvent. In the event that you have run into an error where your system has stopped due to an error, and the flow has stopped, and this is the stop valve is switched to stop. In order to turn it back into normal working order, you can press the button here to switch it back to normal. So right now, the toggle says shut. So if I wanted to shut down the valve so that no flow can be set, then I would click the shut button. If this valve is in the shut position, this button will now be, say, normal. And if I wanted to go back to normal operation, I would click normal to set it back to normal. For the auto sampler, we can change the values of our auto sampler. The main feature that I want to highlight here is the auto sampler wash. Every time you start a new experiment, we always recommend that you click this button right here, and then you set how many mils you want to wash your needle for your auto sampler. Here the default is set at 20 mils per mil, 20 mils. The next thing that we want to do is control our oven. Inside of our oven, we have our column oven and our pump oven, and what temperature we want our column oven to be at, and what temperature we want our pump oven to be at. Right now, both ovens are off, and the value that we want to set the oven, in this case, is going to be 40 degrees. So if I were to change this to 35, then when I click transmit data, it's going to set the new setting to be 35.
Is 40 the minimum?
I would have to double check. So if I want to turn this to 45, then I would transmit to the data to be 45 here on the left. I'm going to turn it back to 40, so I'm going to change this back to 40. Transmit data, and then I'm going to turn both ovens on by hitting these buttons on the right, and now both ovens will be turned on. the next thing that I want to look at is going to be the RI detector. Right now, the current value of our lamp is going to be that it's on. If we wanted to switch it off, I press the off button. If I wanted to auto balance the RI signal, I can click the execute button for auto balance. And if I wanted to turn off right now, because my lamp is on, I want to also keep the temperature control on so that I can get more stable baselines. So right now, because the lamp is on, the temperature control is on. In the event that I am not using the lamp, if I am simply not doing analysis, I'm just flushing the system and the lamp is off, I would also turn off the temperature control for the RI detector as well. So do that. And we also have this settings button on the bottom right. In the event that you want to change your instrument settings, we have a button here for instrument settings. And you can look at information such as you can set the level of how much solvent you have. You can enter information about your column. You can set your column. You can check your column. You can also change your solvent. So this is where we have a sensor, vapor sensor or gas sensor for both your pump oven and your column oven. If you wanted to change these values so that they will trigger a stop for your pump, you can change the threshold for both your gas sensor and for your column oven and for your pump oven. So I think that covers everything for the instrument control.
Could
Yes.
you please walk us through the procedure to change columns and add more columns, please?
Yes. So next thing I'm going to do is showcase how I would add columns. So I'm going to first turn off the pump. So I'm going to turn off the pump so that the flow rate is at 0 mils per minute. I'm going to open this column compartment. So here I'm going to first install my reference column. So the reference column is going to go from your r.pole is going to go into your inlet. And then from the outlet of your reference column, it is going to go into what is called RI-R, which is going to be your tubing for your reference column going into the RI detector. So now this reference column is installed, and I have these column holders that I can place in here and set. So now your reference column is installed. The next thing I want to do is install my sample column. So first thing I would do is take my sample column, look at the inlet, go to my tubing for my sample column. So it's going to be called S.pole, and this is tubing for your sample column. I'm going to place it in here and screw this in. And then the next thing I want to do is connect the outlet of my column into the tubing called RI.S, and then this will go connect to your RI detector. And then I'm going to place this into these column settings, into the column holder right here. So now both the columns are installed. When I am switching to another column, so I'm going to push here to close it. And when I am switching to a different column, what I want to do is operate at very low flow rates. So I'm going to go to 0.1 mils per minute. I'm going to transmit that data. And then after I transmit that data, I am going to click Start Both Pumps. If we were doing sample analysis as well, I would also go to my oven and turn on both ovens as well to make sure those are both on. In the event that you are running two columns for your analytical for your analysis, so this is an error to showcase that that something's going wrong. this will often happen when you open the column oven, when the column oven is supposed to be on. So in the event that, since the column oven is supposed to be on right now and it's set at 40 degrees, and when somebody opens the column oven door, then you'll frequently see an error that comes up. So what I'm going to do here is, so what I'm going to do there is click error reset and click close. And then for whatever error that I see, I will try to remediate that error. Column oven door is closed. So for my pump, both pumps are on right now and they're flowing at 0.1 mil per minute. Once I have warmed up the instrument and equilibrated both of those columns at 0.1 mils per minute, after about 30 minutes to an hour, I would feel safe about ramping up the flow rate. In this case, for these columns, I would ramp up the flow rate to 0.35 mils per minute. So I would enter 0.35, click enter, and then click transmit data. And currently now I have 0.35 mils per minute flowing into both columns. To look at this monitor screen right here on the top left, I'm going to very briefly show you how to navigate this monitor screen so that you can see your acquisition live. So if you right click and hold, you can move your command, your signal up and down. And then if you want to go left and right, you can if you want to go left and right, you can actually slide this gray bar to the left and right to see more of your signal. So right now we don't have enough signal to slide left and right. Right now I'm only looking at the RI. If I wanted to see additional signals, I would right click on the mouse, go to show legends, and you will see a legend of all the different types of signals you can see. So now I'm going to turn on temperature of my pump oven, temperature of my column oven, temperature of my RI, my pressure, and my pressure reference. I'm going to press enter, press exit, and now I will see multiple signal traces. If I wanted to adjust the scale for any of these signal traces, I can right click, go to monitor settings, and then I can adjust the scale for any of my signal traces that I want to look at. So you can adjust their X and Y axis. In the event that I want to change what the primary reference signal is, so right now I'm looking at the signal for my pressure reference, I can click right click, go to show legends, and then I can just click what signal I want to focus on. So let's focus on RI. So right now I'm focusing on the RI signal. I showed you that you can change your settings for your X and Y axis. And if I wanted to, actually I will turn these settings off. If I wanted to zoom in and zoom out, what I can do is hold my right click on the mouse, and then I'm going to slide to the left to zoom in on the X axis. And then so that would be press and hold and slide horizontally to zoom in on the horizontal X axis. And then if I wanted to zoom in on the Y axis, I will press and hold and zoom in. Press and hold the right click button of the mouse. Slide vertically to zoom in vertically on the Y axis. And if I wanted to do both at the same time, I would simply press and hold and zoom in and slide diagonally to zoom in both on the X and the Y axis. So that just about sums up a quick overview of the instrument control using the software and a quick walkthrough through the instrument. Any questions?
Could you please explain why on the diagram, one module, the column oven is brown? Does it mean that it's working towards equilibrium and the other one is red?
So right now, these are going to be colorimetric. So if it's yellow, that means there's an issue. And if it's brown, it should be equilibrating. And then when it's red, it should be ready to go.
Okay, thank you.
Justin, is there anything I'm missing or anything that you wanted to comment on? So if I were to change solvents, what I would do is I'm going to take this. First thing that I would do is make sure that go into my instrument control settings, and then make sure that both pumps are off. Once both pumps are off, I would double check here. I would make my way over to the solvent bottle. I would take this cap off and then take all the lines. I would wipe them with a Kim wipe to make sure they're clean, and then drop them into a different solvent bottle of my choice. Then I will move back. After I have replaced the solvent bottle with my solvent bottle of choice, I would move back to the instrument. And what I would do is go to the pump, and then I would go to purge, press the start button for purge. I would enter 150 mils, because that is how many mils I want to purge the pump with. I would press OK, and it will purge for 150 mils. I would wait until when currently purge says ready, because it is ready to receive a command. When it is purging, it will say busy. I would wait until it returns back to ready, and once the purge is done, I can now flow with no columns on. So this will be done without any columns connected to the instrument. I would flow for about 20 minutes at 1 mil per minute through both pumps. So I will set the flow rate here to 1.0. I would click transmit data, and then I will click start pumps. I'm not going to click it here because I have a column attached right now. And then while I'm doing these steps, I would also go to my auto sampler and click for my auto sampler wash. I would click start here. Was there anything else, Justin, that you think I should cover? Yes. So we have set up for your instrument solvent recycling. So we have these two additional lines. I will label them. One of them is going to be your auto sampler wash, and one of them will be your solvent wash. And when you are only equilibrating the instrument and you're not running any samples, what you can actually do is take these two lines and move them into your solvent water. When you're running this solvent through your system and you're not injecting any chemicals, what will happen is that you're going to be losing solvent to waste. So to make it so that you can save solvent, you would move these two lines into your solvent bottle, and the flow of your